Welcome to the Book Doctor channel. Here, we demystify mathematics and make it fun.
In this question, we are to determine the interval for which the equation is normal. This is a differential equation which is linear and first order. First order linear differential equation. This can be compared to the first order linear differential equation of the form dx dt plus some function p of t multiplying x is equal to some function q of t standing alone on the other side. Comparing our problem to the standard form of this first order linear ODE, our p of t is equal to minus 1 over t squared minus 1. And our k of t equal e exponent minus t in brackets t squared plus 1. For the differential equation to be normal, the function p of t and k of t should be continuous. So the interval for which p of t and k of t are continuous is described as the interval of normality. Let's analyze q of t first. K of t is defined as e exponent minus t in bracket t squared plus 1. The k of t consists of two functions, an exponential function e to the power t. And we know the exponential function is continuous on all real numbers. The other function is t squared plus 1. And this is a polynomial function. For polynomial functions too, they are continuous on all real numbers. So the interval for which q of t is continuous is from negative infinity up to positive infinity. Let's now move to the function p of t. P of t is defined as minus t on t squared minus 1. This function is a rational function. A rational function which is defined as t minus t over t squared minus 1. This function will be continuous except when t squared minus 1 equals 0. The function is not continuous at the point where t squared minus 1 is 0. So what values of t is t squared minus 1 equals 0? We can quickly solve this. T squared will be equal to 1, and our t will be equal to minus 1 or positive 1, plus or minus 1. So the function p of t is continuous on all real numbers except plus or minus 1. So for p of t, or otherwise the domain of p of t, is t such that T is an element of R except plus or minus 1. Combining this with our Q of T, then we can state the interval of normality. Let's locate our -1 and +1 on the number line. It means our differential equation is normal from -1 up to infinity. It is also normal between 1 and -1, but -1 and 1 are not inclusive. And then from +1 up to positive infinity. So can write the interval of normality as from -infinity to -1, close, open at both ends. Union -1 to +1, also open at both ends. Union +1 up to positive infinity. So this becomes the interval for which the differential equation is normal. Thank you for watching. Do not forget to subscribe.